A priori. Let's assume that we're running a grocery store with a very limited selection. We're interested in finding out which items were purchased together. We have only 4 items. Item 0, Item 1, Item 2, and Item 3. What are all the possible combinations in which can be purchased? We can have one item, say Item 0, alone, or 2 items, or 3 items, or all of the items together. If someone purchased 2 of Item 0, and 4 of Item 2, we don't care. We're concerned only that they purchased one or more of an item. What is an item set? A set of items together is called an item set. If any item set has k items, it is called a k-item set. An item set consists of 2 or more items. An item set that occurs frequently is called a frequent item set. Thus, frequent item set mining is a data mining technique to identify the items that often occur together. For example, bread and butter, laptop and antivirus software, etc. What is a frequent item set? A set of items is called frequent if it satisfies a minimum threshold value for support and confidence. Support shows transactions with items purchased together in a single transaction. Confidence shows transactions where the items are purchased one after the other. For frequent item set mining method, we consider only those transactions which meet minimum threshold support and confidence requirements. Insights from these mining algorithms offer a lot of benefits, cost-cutting and improved competitive advantage. There is a trade-off: time taken to mine data, and the volume of data for frequent mining. The frequent mining algorithm is an efficient algorithm to mine the hidden patterns of item sets within a short time, and less memory consumption. Frequent item sets are those items whose support is greater than the threshold value, or user-specified minimum support. It means if A and B are the frequent item sets together, then individually A and B should also be the frequent item set. Suppose there are the 2 transactions, A equals 1, 2, 3, 4, 5, and B equals 2, 3, 7. In these 2 transactions, 2 and 3 are the frequent item sets. Frequent pattern mining, FPM. The frequent pattern mining algorithm is one of the most important techniques of data mining to discover relationships between different items in a dataset. These relationships are represented in the form of association rules. It helps to find the irregularities in data. FPM has many applications in the field of data analysis, software bugs, cross-marketing, sale campaign analysis, market basket analysis, etc. Frequent item sets discovered through a priori have many applications in data mining tasks. Tasks such as finding interesting patterns in the database, finding out sequence and mining of association rules is the most important of them. Association rules apply to supermarket transaction data, that is, to examine the customer behavior in terms of the purchased products. Association rules describe how often the items are purchased together. Association rules. Association rule mining is defined as: let I equals be a set of n binary attributes, called items. Let D equals be set of transaction called database. Each transaction in D has a unique transaction ID, and contains a subset of the items in IA rule as defined as an implication of form x to y where x, y, in x, y equals. The set of items x and y are called antecedent and consequent of the rule respectively. Learning of association rules is used to find relationships between attributes in large databases. An association rule, A equals greater than B, will be of the form: for a set of transactions, some value of item set A determines the values of item set B, under the condition in which minimum support and confidence are met. Support and confidence can be represented by the following example: bread equals greater than butter, support equals 2%, confidence 60%. The above statement is an example of an association rule. This means that there is a 2% transaction that bought bread and butter together, and there are 60% of customers who bought bread as well as butter. Support and confidence for item set, A and B, are represented by formulas. Support, A equals number of transaction in which A appears, divided by total number of transactions. Confidence, A to B equals support of A union B, divided by support of A. Association rule mining consists of 2 steps. 1. Find all the frequent item sets. 2. Generate association rules from the above frequent item sets. Why frequent item set mining? Frequent item set, or pattern mining, is broadly used because of its wide applications in mining association rules, correlations and graph patterns constraint, that is based on frequent patterns, sequential patterns, and many other data mining tasks. Why frequent item set mining? Frequent item set, or pattern mining, is broadly used because of its wide applications in mining association rules, correlations, and graph patterns constraint, that is based on frequent patterns, sequential patterns, and many other data mining tasks. Apriori algorithm. Frequent pattern algorithms. Apriori algorithm was the first algorithm that was proposed for frequent item set mining. It was later improved by R. Agarwal and R. Srikant and came to be known as Apriori. This algorithm uses 2 steps, join, and prune, to reduce the search space. It is an iterative approach to discover the most frequent item sets. Apriori says, the probability that item I is not frequent is if 1. Phosphorus monoiodide less than minimum support threshold, then I is not frequent. 2. P, I plus A, less than minimum support threshold, then I plus A is not frequent, where A also belongs to item set. 3. If an item set has value less than minimum support, then all of its supersets will also fall below min support, and thus can be ignored. This property is called the anti-monotone property. The steps followed in the a priori algorithm of data mining are: 1. Join step. This step generates k plus 1 item set from k item sets by joining each item with itself. 2. Prune step. This step scans the count of each item in the database. If the candidate item does not meet minimum support, then it is regarded as infrequent, and thus it is removed. This step is performed to reduce the size of the candidate item sets. Steps in a priori. A priori algorithm is a sequence of steps, to be followed to find the most frequent item set in the given database. This data mining technique follows the join and the prune steps iteratively until the most frequent item set is achieved. A minimum support threshold is given in the problem, or it is assumed by the user. Number 1. In the first iteration of the algorithm, each item is taken as a one-item sets candidate. The algorithm will count the occurrences of each item. Number 2. Let there be some minimum support, min_sup, e.g. 2. The set of one-item sets whose occurrence is satisfying the min support are determined. Only those candidates which count more than or equal to minimum_sup are taken ahead for the next iteration, and the others are pruned. Number 3. Next, 2-item set frequent items with min_sup are discovered. For this, in the join step, the 2-item set is generated by forming a group of 2 by combining items with itself. Number 4. The 2-item set candidates are pruned using min_sup threshold value. Now the table will have 2 item sets with min_sup only. Number 5. The next iteration will form 3 item sets using join and prune step. This iteration will follow anti-monotone property, where the subsets of 3 item sets, that is the 2 item set subsets of each group, fall in min_sup. If all 2 item set subsets are frequent, then the superset will be frequent, otherwise it is pruned. Number 6. Next step will follow making 4 item set, by joining 3 item set with itself, and pruning if its subset does not meet the min_sup criteria. The algorithm is stopped when the most frequent item set is achieved. Example of a priori. Support threshold equals 50%, confidence equals 60%. Table 1. Transaction. List of items. Solution. Support threshold equals 50% equals greater than 0.5 asterisk 6 equals 3 equals greater than minimum underscore sup equals 3. 1. Count of each item. Table 2. Item. Count. 2. Prune step. Table -2 shows that I5 item does not meet min underscore sup equals 3. Thus it is deleted. Only I1, I2, I3, I4 meet min underscore sup count. Table 3. Item. Count. 3. Join step. Form 2 item set. From Table 1, find out the occurrences of 2 item set. Table 4. Item. Count. 4. Prune step. Table -4 shows that item set I1, I4, and I3, I4 does not meet min underscore sup, thus it is deleted. Table 5. Item. Count. 5. Join and prune step. Form 3 item set. From the Table 1, find out occurrences of 3 item set. From Table 5, find out the 2 item set subsets which support min underscore sup. We can see for item set I1, I2, I3, subsets I1, I2, I1, I3, I2, I3 are occurring in Table 5. Thus, I1, I2, I3 is frequent. We can see for item set I1, I2, I4, subsets I1, I2, I1, I4, I2, I4, I1, I4 is not frequent, as it is not occurring in Table 5. Thus, I1, I2, I4 is not frequent, hence it is deleted. Table 6. Item. Only I1, I2, I3 is frequent. 6. Generate association rules. From the frequent item set discovered above, the association could be I1, I2 equals greater than I3. Confidence equals support I1, I2, I3 divided by support I1, I2 equals 3 divided by 4 multiplied by 100 equals 75%. I1, I3 equals greater than I2. Confidence equals support I1, I2, I3 divided by support I1, I3 equals 3 divided by 3 multiplied by 100 equals 100%. I2, I3 equals greater than I1. Confidence equals support I1, I2, I3 divided by support I2, I3 equals 3 divided by 4 multiplied by 100 equals 75%. I1 equals greater than I2, I3. Confidence equals support I1, I2, I3 divided by support I1 equals 3 divided by 4 multiplied by 100 equals 75%. I2 equals greater than I1, I3. Confidence equals support I1, I2, I3 divided by support I2 equals 3 divided by 5 multiplied by 100 equals 60%. I3 equals greater than I1, I2. Confidence equals support I1, I2, I3 divided by support I3 equals 3 divided by 4 multiplied by 100 equals 75%. This shows that all the above association rules are strong if minimum confidence threshold is 60%. Advantages. 1. Easy to understand algorithm. 2. Join and prune steps are easy to implement on a large item set in a large database. Disadvantages. 1. It requires high computation if the item set are very large, and the minimum support is kept very low. 2. The entire database needs to be scanned. Applications of a priori algorithm. Some fields where a priori is used. 1. In education field. Extracting association rules, in data mining of admitted students, through characteristics and specialties. 2. In the medical field. For example, analysis of the patient's database. 3. In forestry. Analysis of probability and intensity of forest fire with the forest fire data. 4. A priori is used by many companies like Amazon in the recommender system, and by Google for the auto-complete feature.
If you have any doubts regarding this topic, please comment down below. I will respond as per my best. Signing out.